Hello, class. So I'm gonna go over the example that I did today in the class using SolidWorks to simulate static analysis. So this is basically example that I have gone through in a class, which is a torsional bar, and we did static analysis on this torsional bar using SolidWorks. So we're gonna go over that example, and then we're gonna extend the based on the example to a more complicated called design study. Okay. So first of all, model this bar according to the dimension as given in the class. Okay, so those are dimensions. And once you get the model here, so we're going to create a design study. Okay, so to create a design study, so we're going to new study here, okay, and static. Okay. And this is going to be a torsional bar. So first for assign material, I think the material is already assigned, and assign it to AISI 1020. Okay, and we're gonna fix the geometry on this end here. Okay. And we're gonna subject the bar with the torsional loading. So the torque will be applied on this end here. Okay. So and we're gonna apply a torque. Okay. So it says the feasible torque. So here is a feasible torque. Okay. So the second option is axis or cylindrical phase for the direction. So basically, which axis the torque rotates about. So I'll see. I'll let the torque rotate about the axis for this surface, cylindrical surface. So I click on this cylindrical surface. So sorry, it needs to be delete here. Should be this one here. Okay. So there you go. You can see the torque here. Now, if I want a counterclockwise torque, so this reverse direction. We're gonna set the value. Okay. So let's set to 100 pound inch. Okay, that's IPS, so English unit. So that's the torque we have here. There you go. So that's basically all you need to set for static analysis. Okay, and then all you need to do is just to apply mesh or just mesh and run. There, so that's what we get based on results here. Right now you see a lot of deformation in here because deformation scale is set to 174. So you can easily set that by edit the definition in here. So user defines, maybe let's just use one deformation, okay, not that dramatic. The displaced value is 1 mesize stress. The current unit is Newton per meter square, so that's pound. So I'm going to use PSI just to be the same as English unit. Okay, so let's go. There you go. So that's basically the 1 mesize stress distribution along the bar because of loading. As you can see, there's a maximum of this, so which happens around here, right? Basically because of the stress concentration. Okay, so in the class I have gone through the theoretical calculations of how much theoretical value that it will get based on this value, based on the stress concentration and the ratio of the fillet, right, of the radius. And we show that it's pretty close to the value over here. Okay, so that's pretty simple. Now what I'm going to show you is well, the current study is based on a radius of 0.1 inch over here. Okay, so apparently the variation of the fillet radius here will change the stress concentration factor, and alternatively, consequently, it's going to change the maximum 1 mesize stress, right? So as you can see, this is basically in the Shigless table for this type of loading, and the stress concentration factor depends on the ratio capital D over D, the ratio between R over small d here, right? So the smaller R it is, you would expect the higher stress concentration factor, right? Okay, so let's try this. Let's try what if I wanted to have a design study based on basically a different stress constraint factor, different fillet radius at here. Okay. So what I'm going to do is I'm going to create a design study, but before we create a design study here, we're going to create a fixed point here, basically trying to find a point where we want to study. Okay. Okay, so here's what we're going to do. I'm gonna basically insert the plane first. Okay, so here's a plane. I'm gonna insert it here. Okay, so this plane, I'm gonna see 1 inch to this side here. Okay, and then we're gonna create a split. Okay, so over here. Okay, a split line here. Okay, we're going to create a split line between this plane and this surface. So basically intersection between this plane and this surface here. So we create a split line. Okay, yeah. And then okay, we are going to let's go back to model, and then we're going to create another split line. Okay, between the front plane. Okay, so we're going to create a split line between the front plane and this surface. Okay, press Ctrl K and this surface. Okay, so there. Okay, so we've created another split line here. So basically, what I'm doing here, I'm trying to get a point at here and point here. I'm trying to compare. Okay, I'm trying to compare what would be the stress, well, mid-size stress at this point and at this point when the fillet radius changes. Okay. So in order to do that, okay, so we're going to add 2 sensors. So let's add first a sensor at this location here. So the sensor type is going to be the simulation data. Okay, so basically we're going to use 1 mid-size stress. Again, we're going to use PSI. Okay, so where do we want to place the sensor? Try this. So we want to have a sensor which indicates the maximum over the selected entity. So which entity? So this point here, okay, that's the entity. So basically we know that the maximum or mid-size stress happens at this place, right? Because of stress concentration factor. There, so that's the first sensor we placed. And then we're going to place another sensor, okay? So this sensor we're going to place, we'll use the simulation data, 1 mid-size stress, PSI, okay, and select entity. We're going to place this one here. Now, why do I want to play this one? Because we're going to compare the 2 points here. As theoretically, we know that this location, the maximum mid-size stress should not change. Okay, should not change that dramatically because it's far away from this location right here. Okay, so there, I got 2 sensors defined. Now I'm ready to define my design study. Okay, so I'm gonna have a design study here. Okay. So right click at the bottom here, see create new design study. Okay, so we're inside here now. Okay, so basically the first step is okay, you need to pick a variable, which is basically which variable you're trying to change. Okay, in this case, I already created a variable called fillet. Okay, so here this fillet that we trying to fillet is the radius over here. Okay, over here. If it is not created, so you can delete that. Okay, let's see if I want to add a parameter. Okay, so there's already there. So let's suppose that it's not here, right? So if I delete everything here, okay, let's not suppose it's not here. So then what do we do? Okay, essentially you can just simply click on the dimension here. Okay, if the dimension is not showing, right click on annotation, see show feature dimensions. Okay, so if I pick this, okay, oops. Oh yeah, so give a fillet name, fillet, okay, and create select a model dimension. Okay, select the link right here, select this one here. So it shows that at the bottom here. So it shows the model dimension I just clicked, which is a fillet over there, right? Okay. And right now the value is 0.1, right? And the value 0.1. So okay. So now we have the fillet here. What I'm going to do is I'm not going to run optimization, but I'm just let's go to the table view here, right? So essentially, I am going to have different scenarios for the fillet variable. So use enter variable here. So let's say I use 0.1, 0.05, 0.1, 0.15, and maybe 0.2, like this. Okay. So 3 different scenarios for this fillet. The bottom here, the constraint. So the constraint here is this is so-called the optimization problem. So when you got optimization problem, you optimize based on the constraint and subject to a certain goal, so-called objective function. Okay. So in this case, the constraint is could be the sensor that we just defined there. So let's choose stress 3. Okay, so for example, you say, oh, I want to the stress at the location 3, which is this point here, have a maximum or minimum a certain value, right? But in this case, let's see, I'll just see monitor. Okay, I'm not going to do any optimization in here. Okay, so but you can definitely do that. We can also see stress number 4. We can use monitor only for 2. Okay, yeah. As for goals, which is objective function, essentially, for example, you want to minimize something, right, based on the certain goals there. So in this case, I'm not gonna add here because we're not doing any optimization, and we'll be just monitoring, see the effect. Okay, since we're not doing any optimization, we can just uncheck this location here. Okay, so that's basically all you need to do. In the more complicated situation, you can absolutely do a design, so-called optimization design, right? So now let's try to run it. Okay, so so the SolidWorks will run the different scenario, okay, based on your based on the okay, so yeah, something not quite right with my computer, but anyway, so it's still going there. Okay, so there you go. Now it's finished. Okay, so like you have 4 different scenario, right? And it gives the von Mises stress at location here and here. So apparently you can see that the first scenario, right, has the maximum von Mises because the radius fillet is smallest, and then the second scenario, right, smaller, right, and like that, right? So the stress number 4 location is approximately the same. Yeah, the first 2 scenarios doesn't make much difference. SolidWorks. Yeah, that's interesting. So anyhow, that absolutely conforms with the observation from the table, right? So in this way, you have a pretty good idea of what's going on in here by varying the fillet here. Okay. So the other beauty of this SolidWorks, you can output to a Word file of your results here, okay, or you can save everything into an Excel file, okay, for the optimization or your design study. Okay. Now what you can also do is you can right click here and define design history graph. Okay, so over here what I'm gonna do is I'm gonna plot the von Mises stress at the 2 sensor locations. Okay, so check mark. Okay, so we can see that we have the distribution. Okay, we have the stress value, von Mises stress value at the 2 locations. Okay, due to different scenarios, right? And apparently, the location 1, okay, has a drop as the fillet is bigger, right? But the other location is approximately maintain that constant, okay? So that gives you a very good idea, okay, when the variable is being varied, okay, and what would be the stress the part is subjected to due to the variation of that variable. which is a fillet radius at here in this case. Okay, so this concludes the application SolidWorks. For more complicated situations, you can absolutely do more complicated systems, right, using this simple approach. So anyway, let me know if you got more questions. Okay, be happy to answer. Thank you.